Hey my gems, it's Ms. Damaso. Today we are starting our week 5 first video notes. So we're going to be talking about chapter 8.3, data distribution. So we've already talked a little bit about statistical studies. We are now going to talk about what happens when we look at those statistical studies and actually put them into a collection of data. And we're going to evaluate some data as well today. So just as a reminder, of course, you can always go on to the Edmodo account and do your assignment, and you should see the notes there for you, so you can follow along that way, print them off, or of course you can just write them in your notebooks. I think by now you guys have kind of gotten the hang of this, so let's just jump right in. So our essential question today is just how can you interpret the distribution of data in a data set? So if I give you a whole bunch of numbers, I want you to be able to identify it in some way. I want you to be able to interpret the data that's been given to you. So in the data provided below, this is called the time spent getting ready table. We're going to interpret the data's distribution, and we're going to do it a number of different ways. So below, you'll see the average time spent getting ready in minutes, and it's a sample of 17 random scholars at Largo High School, which is great. So what you can see is if I'm going from left to right, my data is already in order for me from least to greatest. You have to take your data and put it in order from least to greatest in order to do some of the things we're going to do later on. So this one's already done for me. If it's not done for you, you will have to put it in order from smallest to largest. So the first thing we're going to do is we're going to construct a dot plot of the data. So a dot plot means that you're going to have a number line essentially. And for each one of these pieces of data, you're going to take that piece of data and you're going to plot it on this as a dot. And so we just kind of build up from there. So I see that there are two 50s. So what I'm going to do is where the 50 is, I'm going to put one dot for the first one, a second dot for the second one. And then I see that I have 1, 2, 3, 4 55s. So I'm going to do 4 55s. And when I do it, I want to try to make sure that I line everything up as nicely as possible. Obviously, it's not going to be perfect, but we try our best. All right, so that's the 55s. I've got 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5. 5 60s. I've got 1, 2, 4 65s. So here's my 65s. And then I've got 2 70s. Okay, great. So that is a dot plot of my data, and you can kind of see where my data is like peaking and where it's kind of like going a little bit lower. So that is one way I can represent my data here. So the average time that the sample of 17 scholars at Largo High School looked like the majority of people spent about an hour or 60 minutes getting themselves ready. Now we're going to construct a histogram of the data using the same data. So histogram talks about the frequency that something occurs. So over on your y-axis, you're always going to have your frequency. How often does it occur? And I'm just going to count these by ones. I don't really need to go much higher than 10. And then on my x-axis is where my data is actually going to go. So that's where my average time is going to go on the x-axis. Now, a histogram almost looks like a bar graph, but it's talking about frequency, how many times something occurs. So I'm going to count mine by, since I have to go from 50 to 70, and I've got a lot of space here, I'm going to count by tens. You could count it by whatever you wanted, but I'm going to do it this way. Now, this means when I construct my histogram, I need to plot this data, how frequently it occurs. So if I'm going from 50 to 60, it looks like 50 is my smallest, right? I want to know how many data pieces or data numbers go from 50 to 60. So I have 6 different values that are in the 50 to 60 range. So from 50 to 60, I'm going to go up to 6. And that's going to be my first bar graph there. So there's 6 of them inside of this. Now from 60 to 70, I have 9. So the frequency of the 60s is 9. So I'm going to come up, draw my bar graph here to 9. So these could have, depending on how you made these different classes down here. So this is considered one class from 50 to 60. Depending on how you did this, if you did it from 50 to 55, well, your graph would look different than mine. Your histogram would look different. Okay, this one's 9. And then the last one is from 70 to 80. It looks like I only have 2, so my frequency there is 2. Oh, I kind of marked it wrong. This should have been 0. I apologize, but you feel me. That should have been 0. I apologize. Made a mistake. Okay, but my graph is still going to look the same as well. So this and this graph are the exact same thing. They are just represented in 2 different ways. Last thing we're going to do, not last, but for this part here, we're going to create a 5-number summary of our data. Then we're going to construct a box plot of our data. So these are probably things you've already seen before: dot plots, histograms, box plot, also called a box and whisker plot. These are things that you've used before, and we're going to use them again here as well. So for the 5-number summary, there are 5 numbers that you need. You need the minimum value, the maximum value. Median means right in the middle, so this is why you have to put it in order from smallest to largest. If you don't put it in order, you're not going to have the median right. Lower quartile is also called quartile 1, and upper quartile is also called quartile 3. And maybe you remember from Algebra 1, this is essentially the median of the minimum to the median, and then the upper quartile is essentially the median of the median to the maximum, and I'll show you what I mean. So right up top, I'm just going to write out my data in order from smallest to largest. And I know it's a little tedious, but it's going to help us when we get to these other parts. So 1, 2, 3, there were 4 of those. 1, 2, 3, 4. Okay, there's 1, 2. 1, 2, 3, 4, 5 60s. There are 4 65s. And there are 2 70s. Okay. So first thing we're going to do is the easiest one, minimum and maximum. So minimum is your smallest value. My smallest value is 50. Maximum is my largest value. My largest value is 70. Now, to find my median, essentially I want to figure out what the center number is. You can either do it by figuring out what's half of 17, or you can count 1, 1, 2, 2, right? So on and so forth. So if I go 1, 2, 3, 1, 2, 3, 4, I'm just kind of working my way to the center. This 60 right here is my median. It's right in the middle. Okay, now lower quartile means not including the median. From here to here, to find the lower quartile, I have to figure out which one of these numbers is right in the middle. So again, I'm gonna do the same thing. It looks like these 2 are in the middle, so I have to find the average of those 2 numbers, but guess what? The average of 55 and 55 is just 55. Okay, so my lower quartile, or quartile 1, whichever you want to call it, is 55. Now I'm going to do the same thing for my upper quartile. I'll do it in a different color. Okay, again, I'm just trying to find the one that's in the center, and it looks like it's going to be between these 2 65s, but again, the average of 65 and 65 is 65. So my upper quartile is 65. This right here is considered your 5-number summary. So if I ask you for that, I'm asking you for these things right here. Now, the mean is obviously the average. So what I need to do to find the average is I need to add up all of these numbers together and then divide by the number of data pieces that I have. I sampled 17 random scholars. So the number I'm going to divide by is going to be 17. So if you add all of these numbers together, you are going to get 1,020. And if you take 1,020 and you divide it by 17, the number of data samples that you have, you will get that the average is 60. The next one is called the interquartile range. To find the interquartile range means, right, like the smallest and the biggest that you have of something. I'm going to take it for the interquartiles. So I'm going to take the upper minus the lower quartile. So my upper was 65, my lower was 55, and if I subtract those two, I get that my interquartile range is 10. Last part is the standard deviation, and I can't show you this right now, but in the comments or in like the description, I'm going to put a standard deviation online calculator for you to use. All you're going to do is plug in the data points and it will tell you what your standard deviation is. For this particular problem, my standard deviation is 6.12. Standard deviation just means what's the average distance that your data points are from the mean. So essentially, the average distance from my mean is 60 is about 6.2 away from it. All right, last part. We are going to construct a box plot. Now, this is again why you need your 5 number summaries. These 5 are going to be what we plot, oh my gosh, in our box plot here. So I'm sure you've seen these before. At each one of these, I'm going to make a vertical line and then I'm just going to connect them. So at 50, I'm going to make a vertical line. At 55, I'll make a vertical line. At 60, I'll make a vertical line. At 65, I'll make a vertical line. And at 70, I'll make a vertical line. Now, the 3 in the center, so this is your lower quartile or quartile 1. This is your median. This is your quartile 3. You'll take these 3 and you will connect them to make a box. That's the box of the box plot. The last 2 parts are called the whiskers. And that is where your minimum and your maximum go. Easy enough, right? And there is my box plot. So I've now represented my data 3 different ways. I've done a dot plot, I've done a histogram, and I've done a box plot. Last part we're going to do is we're going to answer the questions about our data. So, number 1. Does our data have any outliers? If so, what are they? So outlier is something that is like super far away from where all my other data is. All of my data seems to be between 50 and 70. I don't have like one point that's like a 20 or one point that's like 120, right? They're all really close together, so I don't have any outliers within this data here. Just by looking at your diagrams, what value is the majority of your data located? So this value is called the mode. It's the number that repeats itself most often. Well, if I'm to look, I can see it really easily in my dot plot here. It's this number right here. It's 60. That's the number that occurs most often. Number 3, does your median, mean, or both best represent the value where the majority is located? So I know that most of my data is located at 60. If I look up here, my median happens to be 60 and my average happens to be 60. So both of these also occur at the mode. Notice my mean, median, and mode are all exactly the same. So both have a majority of my data. Last one, what type of distribution does your data have? Does it look symmetric or skewed? Skewed just means that it's not symmetric. So symmetric means you should have like a center line and it should be a mirror on both sides, right? Symmetric. If I look over here, it's really, really easy to see in my dot plot, right? It looks like I have like a peak and then it comes back down. This would be like my center line, and it looks like everything on the left is just about, actually it's exactly the same as everything on the right. This is very symmetric data, so this would be a symmetric distribution. We also call this a normal distribution if it is symmetric. Okay. Now we're going to talk a little bit about the shape, the center, and the spread of our data. So the shape of data, the shape of it, so if I were to graph it, right, the shape of it tells me how the data is distributed. The center of the data gives us the middle, obviously, of the data set. Now the middle can either be at the mean or the median. It depends the shape of your graph, and I'm going to show you what that looks like in a moment here. The spread of my data tells me how close together or how far apart the data set is. So it tells me how close together or spread apart the data set is. So again, depending on what the shape is, I'm going to show you in a moment here, you can either use the range, the interquartile range, the mean absolute deviation, or standard deviation to figure this out. And it all depends on the shape of your data. That's like the most important thing. What's the shape of it? Last part is the peak. As I'm sure you can probably figure out, peak is the point where the data is higher than the other parts of the data, right? So if I were to go back to my graphs over here, obviously the 60 is my peak. It's the top of my hill, right? Peak and a valley. So it's the top of my hill here. So if it only has one peak, it is called unimodal. Unimodal. If I have two peaks, it's called bimodal. Multiple peaks, so any more than two, it's just considered a multimodal. Multimodal, that's a fun word. And if it has no peaks, it's considered uniform data. Okay, so let's do an example here. Students were surveyed on how many minutes they spend reading each night. So you can see what the distribution looks like, and I always like to just kind of trace over it because I feel like it kind of shows me what the shape is. So if I look at this shape right here, I say, okay, does this look like symmetric data or does this look like non-symmetric data? Well, it kind of looks like the centers right here and everything on this side and this side are pretty much reflected. So this is definitely considered symmetric data. How many peaks does the graph have? I only really have one hump here, right? I've got one top part, so it's just one. And if it has one, it is considered unimodal. Estimate the center of this data set. Now, this center right here, if I go back to my last ones, the last one we said also looks very similar. And it just so happened that for the last one, my median, my mean, and my mode were all exactly the same. So if I find the average of my data, that's going to be where the peak is. Or I can just look at the peak and go straight down. So I know my peak has to be the average between 15 and 19, this class right here, number of minutes. So I'm going to find the average between 15 and 19, although I'm sure you can figure it out. But if I want to find the average, I can do 15 plus 19, then divide it by 2, which is 17. Okay, so this would be the average, but it's also, so it's the mean, but it's also the median. It's both the mean and the median. And this is because it is a symmetric graph. And that's the only reason why. Because in a moment here, you're going to see ones that are not symmetric, and you can see how it's different. How would you describe the spread of data? It looks like my data is spread out relatively the same between 0 and 34, right? I guess I should back up, right? Between 0 and 34. So my data is spread between 0 and 34 minutes, right? Because we're talking about number of minutes people are reading. And it definitely has symmetric data from the center. So it creates symmetric data from the center. Okay. Now, data sets can be categorized by how they are shaped. There are 3 different possible shapes of data. So the first one right here is symmetric. This is the one we've been looking at. It almost looks like there's a line in the center and everything on both sides of that line is exactly the same. It's symmetric, right? It's a mirror image. There are 2 other types of data that are called right and left skewed distribution. Skewed just means that it is not symmetric. It's pushed to one side. If you look, this first one's called a left skewed distribution. The hump is on the right, or the peak is on the right, and the tail is on the left. So the tail is why it's called a left skewed distribution, which makes the other side a right skewed distribution. That means the tail is really far over here on the right side. Now, if you're looking at a graph, it looks something like this. If you're looking right, and so again, you can kind of see it. Looks like that. Whereas this one's got the hump and it comes all the way down like that. And this one looks symmetric. So it's pretty easy typically to tell between these what kind of data it is. The other way you can see it is also with a box and whisker plot. So what's important here for a left skewed distribution is that the mean is less than the median. It has a long tail on the left. It's also called a negative skew. So you might see left skew, you might see negative skew. For a symmetric data, it looks like a bell. It's bell-shaped. The mean and the median are exactly the same, or they're very, very close to each other. So they might be, just a few decimals off, but if they're really close, they're symmetric. Last one is a right distribution. It has a positive skew. The mean is greater than the median. That's important. And it has a really long tail on the right. All right. Now, here is how you will determine how to measure the center and the spread of our distribution. So I talked a little bit before, standard deviation is just a measure of how much the values in a data set vary from the mean. So it's how far away they are from the mean. It's a measure of variability or spread of the data. So we use an online calculator to determine that standard deviation. So here's how you're always going to figure out how you're going to measure the spread and how you're going to measure the center. If the data is symmetric, so yes, it is symmetric, you're going to use the mean to describe the center, and you'll use the standard deviation to describe the spread. If the data is not symmetric, then you're going to use the median to describe the center and the interquartile range, which we did on the other page, to describe the spread. Okay, so now we're going to do some practice problems. We're going to figure this out. I'm also going to move us back because the sun is coming. I gotta get the sun out of the way. Okay. Practice problem number 1. I've got a graph with distribution A and distribution B. We're gonna use that graph to answer the following questions. Letter A. How do the shapes of the 2 distributions compare? So here's distribution A. It's this one right here. Green. And then distribution B is this other one. It looks like it's lower down here. Okay. If I'm looking at graph A, I say, is that symmetric or is that skewed? Well, graph A is definitely symmetric. Right? So it looks like a mirror image. If I look at graph B, well, maybe it's lower down, it still looks like it's symmetric. Now, if I'm looking at the spread, how far these two have their data spreading out, if I'm looking at distribution A, it's the green, it looks like I go from 2 to 12. That distance would be, from 2 to 12, it's 12 minus 2, right? So that would be 10, is where my data is spread. Now, if I look at distribution B, my spread goes from 0 to about 14. So my spread for B is 14. So while they're both symmetric data, the spread of A is definitely less than the spread of B. Most definitely. Okay. Letter B. Which measure of center would best describe the data? Now, I'm measuring the center. Center is where the peak is. And these happen to be right about the same spot. Now, they are symmetric. Because they are symmetric, I am going to use the mean to describe the center. So, for both A and B, I am going to use, do it in a different color, mean, because they are symmetric. Okay, last one. How do the centers of the two distributions compare? Well, if I look at graph A, or distribution A, if I look for the center, it's where the average is. It's the same spot the peak is. It looks like it's at 7. If I look at distribution B, the center looks like it is also at 7. So the centers of my two distributions are equal. They're exactly the same. All right. Number 2. We're now going to use this second graph to answer the same sorts of questions. So distribution C will be this green one. I'm not going to do the whole thing. And then distribution D will be this pink one. Okay. How do the shapes of the two distributions compare? So if I look at C, this definitely looks like it would be a symmetric graph again. And if I look at graph B, or excuse me, graph D, again, this looks like a mirror image. Oops, that was supposed to be a C, my bad. I was looking at the last one. Okay. This one also looks like it would be symmetric. Now, let's talk a little bit about their spreads. This one, letter C, looks like it goes from about 0 to 10. So my spread is about 10-ish. It's a little off. And if I look at my distribution D, my spread looks like it goes from 5 to 15, which again happens to be 10. So I would say for this one that my spread of C is equal to my spread of D. Which measure of center would best describe the data? Well, because they are both symmetric, just like the last one, I am going to use the mean because they are symmetric. Now, if I look at their centers, the center of C looks like it's like, I don't know, we'll call it like 5.2. And then the center of D looks like it's at 10. So obviously, the center of C is less than the center of D. Oh, that was the next question. I did them both, my bad. So this one was just which measure, this one's how do they compare. Center C is definitely less than the center of the distribution D. Now, we're going to determine whether each statement describes graph 1, graph 2, or both for the ones that we just did. Letter A, there's a difference in the typical or mean data value between the two data sets. So which one of these has a different mean or center? Well, it looks like these two have the same average of 7. These two have different centers of 5-ish and 10. So there's a difference in the typical data would be graph 2. The mean and the median of the two data sets are the same. Okay, mean and median mean that the center is at the same place. So again, if they're in the same spot, that looks like it would be this graph, graph 1. Okay, last one. The mean of one set is greater than the mean of the other set. Well, that should be easy because in this one they were the exact same. In this one they are different. So it looks like this would be graph 2. Okay. Now, for each box plot, we are going to describe the distribution of the data. So let's go through, let's just do some, let's just start with the shape, if it's symmetric or if it's skewed. So if I go here, it kind of looks like, whoop, that's where my hump is, right at this line. This looks like it's pretty much symmetric. It's maybe a little off, but we're gonna say that's symmetric. Okay, number 2, it looks like I've got a really long tail, and then the hump would be over here where the center line is. That's the median, right? So I've got a really long tail on the left, so this would be considered skewed left. In graph C here, it looks like my hump goes up here, comes down, and then I've got a really, really long tail over here on the right. So because I have such a long tail on the right, it is skewed right. Okay, last one. It kind of looks like this is almost right in the center, doesn't it? It looks pretty symmetric to me. Okay, now, are we going to use the median or the mean to describe the center? Well, if it is symmetric, I'm going to go back to my little chart here. If it is symmetric, I'm going to use the mean. If it is not symmetric, I'm going to use the median. So, this first one's symmetric. That means I'm going to use the mean. Graph B is skewed, so I'm going to use the median. Graph C is skewed, so I'm going to use the median. And graph D is symmetric, so I use the mean. Okay. Now, to determine the spread, should I use the IQR, the interquartile range, or should I use the standard deviation? Well, if it is symmetric, I'm going to use standard deviation. If it is not symmetric, I'm going to use the IQR, interquartile range. Excuse me. So this first one is symmetric. So because it is symmetric, I'm going to use the standard deviation. I'm not going to write the whole thing out. Graph B, because it is skewed, I'm going to use the interquartile range. Graph C, because again it is skewed, I'll use the interquartile range. And then graph D, because it is symmetric, I will use the standard deviation. All right, last question. Do you have any outliers? You will only have outliers if you have a skewed graph. So because my graph is symmetric for the first one, I have no outliers or none. If it is skewed, you will have an outlier, and your outlier will be wherever your tail is. So it looks like my outlier is at about, we'll call that like 30. Graph C, do I have any outliers? Yes, it's where this long tail is. So I would say, let's see, 85, 95, that's probably like 100-ish. And then graph D, because it is symmetric, it does not have any outliers at all. Okay, last part, number 5. People were asked if they owned cats or dogs. The data is organized into 2 histograms below. Determine if the statements below about the data are true or false. If the answer is false, explain why. So I'm going to go through, I'm going to draw my little distribution here. This would be where my center is. This one looks something like this. Okay, this one definitely looks like it is symmetric. This graph over here looks like I've got the hump on the right and the long tail on the left. So this would be skewed left. Okay. So first question, letter A. Both distributions are symmetric. Well, look at that. Already I know that that is false, because the cat owner ones is skewed left. Letter B. The center of the cat owner's data is higher than the center of the dog owner data. So the center is where your peak is. My center for the cat owners looks like it's between 6 and 7, so we'll call it 6.5. And then the center for the dog owners, again at the peak, looks like it's between 4 and 5, about 4.5. So the center for the cat owner data is definitely higher than the dog owner data, so that is true. Okay, letter C. Either the mean or the median is the best measure of center for the 2 sets of data. So they're saying you can use either one. Well, I know if it is skewed, then that means I have to use the interquartile, or excuse me, I'm at the center. I have to use, yeah, it is the center one. I have to use the median for this problem. I can't use the mean. I must use the median. So this would be false. So for the cat one, I want to use the median. And for the dog one, because it is symmetric, I'm going to want to use the mean. The 2 sets of data seem to have similar spreads. Well, it looks like I go from 0 to 8-ish, a little more. Same sort of thing over here. They look like they're both spread out about the same distance. So I would say, yes, this is true. They both look to be about the same spread. Okay, last question. If the mean is chosen as the measure of center, then the IQR is the best measure of spread. So I go back to my little chart. If I choose mean, I have to use the standard deviation to describe the spread. So this one is a false statement. So if you use the mean for center, you must use standard deviation for the spread. Okay, we are now finished with our week 5 video 1 notes. I will say that it is probably a really great thing if you have this page here printed off, because this is really like your cheat sheet for all of the problems from here on out, okay? So You're now ready to go to your week 5 video 1 homework, which you can find inside of that Edmodo document. I've had some people ask me questions about this. You are free to print it and do the work, or if you don't want to print it, if you just want to do it on notebook paper and then turn it in that way, that is also okay. You do not have to print it. That is just an option if you like doing that. If you guys have any questions, please feel free to reach out. I'll help you out the best I can. And please make sure that you do it through Edmodo, because it's the easiest way for me to get in touch with you, because I can text you back pretty quickly. All right, so go ahead, you guys can go into your homework. Have a really grand day, and I'll hopefully speak with you guys soon.